Welcome to this episode of the Georgia Highlands College Chemistry Podcast. I am Dr. Harvey Moody, Professor of Chemistry at Georgia Highlands College. I hope you find this topic helpful. Welcome to today's podcast. In this podcast, we will be discussing Lewis structures. Lewis structures are also called Lewis dot diagrams or electron dot diagrams. These diagrams show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. The Lewis structure was named after Gilbert N. Lewis, who introduced it in an article in 1916 defining the atom and the molecule. This article, The Atom and the Molecule, founded the valence bond theory that we are using in this area. Lewis structures show each atom in the structure of the molecule using its chemical symbol. Lines are drawn between atoms that are bonded to one another. Excess electrons that form lone pairs are represented as pairs of dots and are placed next to the atoms. Chemical bonds refer to the attractive force that holds atoms together in compounds. There are two major classes of bonding: ionic bonding and molecular bonding. Ionic bonding results from the electrostatic attractions among ions, which often results from the net transfer of one or more electrons from one atom or group of atoms to another. On the other hand, covalent bonding results from sharing one or more electron pairs between two atoms. These two classes of bondings are the extremes that we'll use in the valence bond theory. This podcast will deal primarily with molecular or covalently bonded compounds. We have learned that atoms tend to gain, lose, or share enough electrons to become surrounded by 8 valence electrons. This is known as the octet rule. So how are we going to write Lewis structures? We will use a set of 5 rules. First, we will draw the skeletal structure based on the formula that is given. Then we will determine the number of valence electrons in the molecule by adding up the valence electrons of all atoms. And then we will subtract 2 electrons for each bond that has been created in our skeletal structure. Then we'll count the number of electrons each atom needs to satisfy the octet rule. And if the number of electrons that the atom needs equals the number of pairs remaining, then we will satisfy the octet rule by placing electrons as pairs around the atom. For example, we're going to write the Lewis structure for ammonia, NH3. In ammonia, the skeletal structure is the 3 hydrogens bonded to the nitrogen. In this case, how many electrons did this molecule originally have? Nitrogen, group 5A, 5 valence electrons. Each hydrogen, 1 valence electron. So we have 8 valence electrons to place in this molecule. At this point, we have 3 bonds. Each bond consists of 2 electrons. So we've used all but 2 of our 8 electrons. Hydrogen is an exception to this rule. It has 2 valence electrons. Nitrogen has 6, so it needs 2 to have 8, so we're going to place the remaining 2 electrons around the nitrogen as a lone pair. So we can see that in ammonia, the nitrogen has 3 pairs of bonding electrons and 1 pair of lone electrons. Another example, write the Lewis structure for formaldehyde, H2CO. Okay, the skeletal structure is 2 hydrogens bonded to a carbon and the carbon bonded to the oxygen. Now, before we look at our new rule, we're going to determine how many electrons available in this molecule. Each hydrogen has 1, so that's 2 for the hydrogens. Carbon has 4, so that's 6, and oxygen has 6. We have 12 valence electrons to place in this molecule. We have used 6 electrons in the bonds, so we already have 6 valence electrons remaining. For each atom to have 8, carbon needs 2 and oxygen needs 6. So in this molecule, we need 8 more electrons. We only have 6. We do not have enough electrons. So a rule that if we have fewer electrons remaining than those we needing, for each 2 electrons that we need, we form one more bond. So this means that for formaldehyde, we will create another bond between the carbon and the oxygen. This is called a carbon-oxygen double bond. This double bond contains 4 electrons. We could not have put this bond between carbon and hydrogen because that would have exceeded the octet rule for the bonds or the number of electrons between hydrogen and carbon. At this point, each hydrogen has 2 electrons, the carbon has 8 electrons, and the oxygen needs 4 more. So we put those 4 as 2 lone pairs around the oxygen. At this point, oxygen has 8 electrons. So the octet rule for oxygen has been satisfied. If we count up the total number of electrons used in this molecule, we will see that we have 12 electrons used. We've used all of our valence electrons. We've not created any or destroyed any, but we've used all of our electrons in the formation for this Lewis structure. Another example, let's write the structure for sulfur tetrafluoride. The formula implies that the 4 fluorines are attached to the sulfur. Again, the way I have them attached here is not representing the actual angles of the molecule. The Lewis structures do not predict that. So how many valence electrons are in this molecule? Each fluorine has 7. So 4 times 7 is 28. Sulfur has 6. So that means we have 34 valence electrons in this molecule. We've used 8 in the bonds. So that means we have 26 electrons left to satisfy the octet rule. Sulfur has 8 electrons, so its octet rule is complied with. Each fluorine needs 6, so 4 times 6 is 24. We have 26, so we have enough electrons. So we place 6 electrons in 3 pairs around each fluorine, and then we put the extra electrons around the central atom, sulfur. In this case, we can see that sulfur in sulfur tetrafluoride is an exception to the octet rule. It has 2, 4, 6, 8, 10 electrons around it. So it exceeds the octet rule. So as a general rule, when we have extra electron pairs, we place those around the central atom to form our Lewis dot structure. This has been a very quick summary of how to draw Lewis structures. I hope that helps you in your understanding of Lewis structures. Have a good day, and we'll see you at our next podcast. Thank you for listening to this episode of Georgia Highlands College Chemistry Podcast. We hope this episode has helped spark some interest and excitement in chemistry. We look forward to sharing more chemistry podcasts with you in the future.